story about protein synthesis. I need you to be very quiet and I need you to listen because I would like to get through this at least one complete time, okay? And then I will do the story again, and when I do it the second time, I will take questions. Got it?
Yes,
All right, so I'm going to tell the story completely all the way through. This is the story of protein synthesis and how a protein is being made, because the word synthesis means what? To make. Good job. All right, so DNA is a really big molecule. It's too big to come out of the nucleus. It has the instructions for how to build a protein. Are you focusing on the board as well? Okay, so they can see this. All right, so what does DNA do? It opens up. How do you know this is DNA and not RNA? Somebody tell me.
DC?
Say it again.
No.
It has the T's in it. Those T's stand for thymine. I get it when you don't know how to say these words. That's fine. So you can always just say the letter and I will say the word. Okay? So it has T's in it. DNA has T's in it. Alright, so again, DNA has the instructions. It needs to send a text message that it's grounded and it can't get out of its room. Its room is the nucleus, and the mom has taken the cell phone up. Okay? So, DNA opens up, and RNA, using the base pairing rules at your grandma's crib, which is written right here, okay? Using the base pairing rules for RNA, it comes in here, and it takes the message. Okay, so what is DNA doing? It is scribing the message. Okay, the word scribe means to write. Remember last week we talked about the court reporter? The lady or the man that sits up here and they type everything that's happened in the court case. Okay? So it scribes the message. DNA scribes the message over to RNA. How do we know this is RNA and not DNA? The U's, absolutely. It has uracil in it. It has no thymine. Okay? It has uracil. Alright, so it has taken the message through the process of transcription. The word script means to write. Okay? Alright, so it scribes the message over. DNA then zips back up, stays in its room or its home. Okay? Without its cell phone. This guy right here, RNA, snuck through the window and got the message. It can get out because it's not too big to get out of the nuclear core of the nucleus. So the messenger RNA comes out of the nucleus, goes through the cytoplasm, and goes to the ribosome. Okay? The ribosome, you can go ask her. Our other teacher in the class, you can go ask her. The ribosome then speaks, are you listening? The ribosome speaks Spanish.
What?
The ribosome, I said that wrong. The ribosome, okay, speaks English. And the messenger RNA speaks Spanish. They need to be able to communicate with each other. Alright? So, what has to happen? Something has to come in and translate for them. The translator is tRNA, which is transfer RNA. It translates the message from rRNA to messenger RNA. Now, here's the question I have for you. How do you know this is messenger RNA and not transfer RNA or not ribosomal RNA? You know that because of the shape of them. Messenger RNA is always in a line, like this. And it's a whole bunch of bases. It could be this long or it could be way longer. It depends on what protein that it's building for the body. Understand? All right. So, messenger RNA does not speak the language that ribosomal RNA speaks, so they have to have a translator, the tRNA, which is actually called the transfer RNA, but it is the translator. This process is called translation. All right, translation. All right, so the translator comes in and it gets on the first codon. Recall from the last time I was here that this is read by codons. A codon is 3 consecutive letters in messenger RNA. So the first codon is AUG. The second one will be GGC. The third one will be AGU. The fourth one will be GUC. And the last one will be UAA. Understand? Okay. Are these letters always like this? No. Because remember, we learned that DNA is unique to each organism. Every organism has different DNA. So even though you have a lot of DNA that's similar between you and your brother, or you and your sister, or you and your mother, or you and your father, okay, it's not going to be exactly the same. So this right here will be different, except for one thing. It's always going to start with TAC. And this is always going to be ATG. You'll learn why in a minute. Okay? And it has to be this because this one always has to be AUG, which is the start codon. There is only one start codon, and it's AUG. To build the polypeptide chain, you have to start with AUG, the start codon. Understand? Okay. And then you always have to end with a stop codon. You will learn what a stop codon is in just a moment. All right. Do you think the video is getting too long?
No.
Okay. All right. So I'm going to put this back over here where we were. Okay. So the AUG is going to translate, or it's going to talk to, the UAC. This is the codon. So if this is the codon, this is its arch nemesis. It's just opposite of it. Okay, is everyone looking? So A goes with U goes with A, G goes with C. Why is there no T in this?
Because it's the
Why is there no T in this
it's the
one?
foam.
Because it's RNA.
Yeah,
So
yeah.
why is there no T in this? A with T.
Because there's no T in
Because
it.
it's RNA.
RNA.
Okay. If it has U's in it, it's RNA. And it's always going to start with AUG and UAC. Got it? All right. So this is transfer RNA. Everyone's looking. Everyone's listening. All right. So my serine is missing. So we're going to pretend for right now this circle is not up here. Got it? All right. So now we're going to go through translation. The process of translation. So the ribosome has rRNA, and the rRNA and the messenger RNA or the mRNA do not speak the same language. Okay? I also want you to look at the shape of this. It looks like an old-timey key to me. Like from back in the 50s.
Yeah, it kinda does.
And the 30s, okay? They're really big keys, and every key was pretty much the same for a lot of those locks with minor differences. They were real easy to pick. Just saying. All right, so here we go. So they don't speak the same language, so AUG. So I would like for everyone to look at this textbook right here. It's the one with the whale on it. Turn that book, open that book to page 292.
So I need to get a book to show in it.
296.
Just come over here and 292. So focus on this for me, please. This
Focus.
is called a codon chart. So, now focus back up here. Would you ever read a codon chart from an anticodon? No, it's not an anticodon chart. It's a codon chart. Do you understand? All right, so you're going to look at A, U, G. I'm going to teach you how to do this. Can I borrow you?
No. I have a price.
When you have Okay, so if you would hold this for me. Oh, let's fold it in half.
You gotta model it, like,
Right? Okay,
there you go.
so this is the wheel. So back in about 2004 or 5, they told us they would start using the wheel. They never have. That they've never told us that they wouldn't use it. So I will teach you this. There's a 1% chance they'll use this. They've never used it. So I'm going to tell you they are going to use this one. This is the same thing as the one in the book that you're looking at. All right? So, tell them I'm extremely busy and I'm being filmed. All right, so I'm going to teach you how to use it. Take your left finger. Do you see where it says in your book, it says first letter? Here's the A. Put your finger on the A where it says first letter. Okay? The next one says second letter. Put your finger up there. The second letter is a what? First three, we're looking at it. What's the second letter? U. That's right. U. Okay, good job. You're going to Superman it, hey? All right, so here. The second letter is U. A and U meet up in this big square with 1, 2, 3, 4 things. So now you're going to leave only your left finger there. Now, in your book, those 4 things are leucine, isoleucine, 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 methionine. Now, those are big science words. You do not have to say the whole word. All I want you to say is the first 3 letters. If you can't pronounce it, you would just say ISO. Okay? ISO. So it's either isoleucine, 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 or it is methionine. Okay? Do you understand? You're not in that, you're using the book. Please use the book. Use the book. All right, let's start all over. We're going to start with our A. The A is first letter. Do you see first letter? Go down until you find the A. The U is the second letter. These two meet at isoleucine, 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 methionine. Take your right hand off. The last letter is a G. So go to the third letter. Go to the G. Where does the A and the G meet? At methionine, or MET. Does everybody see that? Yes. If you do not, you need to raise your hand and let me know. Okay, hit pause.